Thanks for joining today for our session on modernization on AWS. My name is Hari Zahir Ahmed. I'm a solutions architect at TecBrix. So I have been with TecBrix for the past 3.5 years, and I have the privilege to migrate and modernize multiple infrastructures on AWS. So in our agenda today, we will be discussing about the pillars of modernization. What are the migration and modernization patterns? What are the advantages of multi-account architecture, and why AWS for modernization? Plus, how TechBricks can help you in order to achieve the migration and modernization goals. Plus, at the end, in case if you have any questions and answers, you can ask. So, to begin with, let's discuss about the pillars of the modernization. What are the things involving the modernization journey? For example, when an organization wants to migrate and modernize on the AWS cloud, we are not just talking about the modernizing the technology or architecture. So we'll be talking about modernizing the technology, the architecture, the way your people work, about your work culture, plus your operations and governance, and everything how we can manage it at scale. So we'll be talking about each and everything when we talk about modernization. Now, many organizations and they may feel that only migrating and modernizing the technology or the architecture is enough in order to achieve the modernization goals. The modernization is the refactoring of the legacy technology plus the refactoring of the operations, the organization patterns, which the people how they are working together, the tools and technologies we are using. So everything we need to modernize to maximize the benefits of the cloud adoption and to maximize the benefit of the new technology. So let's discuss about the migration and modernization patterns. So when we are migrating from our on-premises to AWS cloud, there are 7 Rs which we can choose. The first one is rehost, is a simple lift and shift migration. Plus the other one is relocate. So these two patterns of migration are very easy, and many organizations choose these patterns to migrate to the AWS cloud. The reason is that these includes less complexity, and while you move forward, the complexity might be higher. So the average the customers, like 30 to 40 customers, they plan to rehost. They want to lift and shift to the cloud. They want to migrate their existing operations, their existing applications on the cloud. And while they are migrated, then they want to modernize their environment, because the modernization includes the replatforming and re-architecting, refactoring of their applications. So once you are migrated to the AWS cloud, you can plan to re-platform, where you, for example, you can migrate your databases from virtual machines to AWS managed databases. So once you are re-platformed, then you can plan to migrate your application from simple EC2 virtual machine to go serverless or to go containerize. And then if you have any legacy application which you are managing in your organization, you can move to a SaaS platform which can do the same job for you. So migration plus modernization is a journey of continuous improvements. Even we are migrated to the AWS cloud, that's not it. We need to continuously modernize our environment so that we can continuously improve and increase our efficiency. So while we are migrating to the AWS and then modernizing, we need to understand the our portfolio, like what are the applications which we are planning to migrate, what is the portfolio, what are the servers, what is the dependency of each applications, what is the usage utilization of each application and workload which I am planning to migrate to the AWS cloud. For example, when you do the portfolio assessment before migrating, let's say you have hundreds of servers and more than 50 applications. When you do the portfolio assessment, when you do the discovery of your existing portfolio infrastructure and workloads, you will see that there will be many applications which you can go retire that are there in your own premises system but are not being utilized. No one is using them, so we can retire those applications. Plus, there are some legacy applications which are doing some particular job, let's say any CRM system. While migrating to the AWS cloud, you can retire those and you can plan to go SaaS. You can use software as a service for that. Plus, you can find your applications which you want to lift and shift. So we can just rehost those applications as it is, which you are running on your on premises. We'll run it on AWS cloud, and then the more than 30% of efficiency and cost benefit comes from this refactoring and replatforming. When you refactor your application, for example, if you're running the databases, let's say SQL Server and Oracle databases, so while migrating to the AWS cloud, we can choose Amazon RDS service as a managed database service. So you will not be doing any manual tasks which you were doing on premises. It will increase the efficiency of your IT staff as well. And replatform. So if you are using, uh, let's say the database, you can migrate to the managed one and we can refactor your applications. So for example, if you're running a monolith application, we can plan to refactor into microservices and deploy it on, let's say, AWS serverless Fargate offerings. So we need to avoid these pitfalls. So many organizations, when they are migrating from on-premises to the AWS cloud, they want to prepare a bridge. So they can prepare a bridge where they can migrate their applications easily from on-premises to the AWS cloud. That's perfect. But what they do is they take the obsolete tools, they take the old methods of doing few things, and they want to manage the infrastructure. They take all these things with them over the bridge. So what it happens, so you prepare a bridge, you migrate to the AWS cloud, but you didn't see the actual benefit of AWS and adopting the cloud and the latest technologies. The reason is that you are taking everything with you. You are taking the complexity of your applications. So it will not give you the full benefit. So what you need to do, so AWS offers a lot of wide range of services over there, which can lower the cost, which can improve the performance of your application, which can improve the time to market, which can improve the agility of your application, and which can help you to go 10 times faster than you were in your on-premises system. So what we need to do is while migrating to the AWS cloud, while from the bridge, while adopting the more innovation, we need to make sure that we are not taking the obsolete apps with us. Even we are either we are refactoring those applications or we are retiring if they are not being used. So if the applications and if the processes are too complex, we need to break down them into smaller chunks, whether it's application teams or whether it's the application code. If we can divide them into simple microservices and then migrate so that we can get the full benefit of the migration of the AWS cloud. So usually in the big projects, what happen is that we have a very big project and we will be discussing about the ROI of the project. Like if we do the full migration of our portfolio, we migrate the 100 servers. What will be the return on investment we'll get while migrating to the AWS cloud? So in the big projects, we need to make sure that we are taking care of a lot of things. So we are not just migrating the infrastructure. So we need to make sure whatever we are doing, we should be doing in the right way. So we don't need to, burn big money over this if we have a very big investment cycle. So we don't need to create our project so big that we can make all the processes complex. So we need to divide our journey into small chunks. We need to create the migration waves. We need to create the migration plan. So historically, if we are planning something, we should be planning big. But in the latest era, we need to plan small chunks. Even if we are migrating, we need to create the migration waves. Let's migrate the low-hanging fruits first. For example, let's migrate the simple applications which we can lift and shift, 3 to 4 applications. Then migrate the applications which we can re-platform from, let's say, on-premises virtual machines, the Oracle databases you are migrating to the Amazon RDS. So we need to plan our journey accordingly. So let's discuss about the monolith architecture. So we usually seen that many applications which are running on the on-premises are running on the on-premises for on the monolith architecture. So it is having everything, all the application components in a small, in a very big, architecture. So it has everything within a same box. So what we need to do is we need to make sure that while adopting the cloud, we need to change this. We need to divide our monolith applications into the small microservices in order to gain the full benefit of the cloud. So the single monolith application, you must deploy the entire application. You cannot deploy the database as a separate layer, or your data access as a separate layer, or application backend as a separate. You need to deploy it as a full organized unit and run it as it is on one technology stack for your entire application. So we have seen that if you are working with the monolith architecture, you will be having many developers working on the same application, pushing changes to the same monolith applications, releasing, the release pipelines will be the same, which can cause many troubles, and your efficiency is very, very less. So you will not be able to, go to market on a very high pace or build new features. If some developer is pushing or making changes to databases, maybe it will affect the data access layer, or maybe it will affect the application logic. So a monolith architecture comes with a lots of drawbacks. So if you want to, let's say, you have a problem in your monolith application and you want to do a quick push in your application, and it's a very important fix. While merging it, you need to make sure that all the teams are aligned with you. You are testing everything in the staging, and you are testing everything in the dev environment, let's say, and making sure that all the other components are working in this monolith application, and then you will push it. So we'll see that how we can, get rid of this monolith architecture. What are the AWS services which can help us in, migrating from monoliths to the microservices architecture. And in on-premises, we've seen that there are many repeatable tasks which we can automate, but many tasks are executed manually. For example, if there is a service request, we will be doing it as a manual resolution. So we will be maybe raising a request. For example, in the on-premises and mostly in the monolith applications. So if there is a service request with the manual resolution, many organizations are still, relying on it to fulfill the task. Create a request. The teams will see the request, and then they will, create a routine or a time, and then they will do the job, and then we'll see the outcome of it. Sometimes the security approvals take a lot of time. If there is a security, fix or a guardrail to implement, many organization workflow will require owners to submit their workflows for review to ensure that it is aligned with the security best practices, and it will not impact anything else which is running in your system. So all these manual tasks, so it decreases the efficiency, and it let you to the wastage of time, and your resources who can work on some other productive tasks are still working through these approvals and stuff, and your developers and the QA engineers are doing the manual deployment and doing the manual testing of your applications. So if something can take like 1 hour in the modern architecture, in the modern infrastructure where everything is automated, if you're doing it's the same thing manually, it can take up to 2 3 days. And also one pitfall we have seen that the organizations do in or while they are migrating from the from on premises to the AWS cloud is that they have all the single team, a unified team in which they have different people and migrating towards the same goal. So this is something not this is something we need to avoid. So we need to make sure that all the teams who are working with each other, there should be a chunk of smaller teams who can take a one smaller part and work on together and do the job. For example, for the operations, for the database administrator, for the security, we have multiple teams, many individuals in each of the team, and they are working together with each other and do the job. What we need to do is we need to take one individual of the each of the team, prepare a small team, and do the job. It doesn't matter like what technology we are using or what how complex the the task is. If those teams work on a smaller chunk of a big part, the efficiency increases. So what we need to do is we need to have a two pizza team where members where small members comprises of a team, and then they can communicate with each other even through some different tools or through interfaces, or by sitting together and work on a smaller part of a big journey, of a big migration, and work on that. So we need to avoid that all the uniform team marching towards the same goal on a big goal. So if you are achieving a very big goal, you need make sure that you need to divide it into the smaller chunks. And we can increase the productivity through the automation self-service guardrails. So for example, while migrating to the cloud, you need to make sure that whatever the uh, the operations, the tools which you are using on the on premises, we need to modernize those tools, those practices as well. So we need to engage automation in each and every task. So we can create a baselines towards the catalog with automation, automated provisioning. So if we want to create the infrastructure on AWS cloud, we can create a service catalog that this team can produce this service catalog. Once they will deploy this a template, it will create the infrastructure for us. So that infrastructure is ready to host the application, and we can implement the security guardrails to enforce baseline and increase agility. So every time if we are creating a new AWS account, or if we are deploying new workloads on the AWS cloud, we need to automate the implementation of security guardrails. For example, we can automate it by using a control tower. If we create a new account, it will automatically implement all the new guardrails, all the new security baseline into the new AWS account. Plus, we need to make sure that we are using CI/CD with gates and static code reviews, automated testing, and security scanning. So AWS has a full set of services, developer tools, which we can use. So if we are manually deploying our application code, we need to make sure that we are creating a CI/CD pipeline. So once your developer will push the code to the, let's say, to a branch, it will be automatically tested. You can implement the unit testing, and you can implement the security testing as well. Once the tests are passed, it can deploy to the, let's say, staging, where we have some manual checks again, depends, or we can have some automated testing, and then it can deploy to the production. So we can automate each and every task which we used to do manually, to increase the efficiency, to reduce the time, so that we can spend time on more other productive tasks. So automating everything is a one-time effort where you need to put a lot of effort initially in order to do this automation. But once it's done, you will be having a lot of time to 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 spend it on some other business driven task, or doing some more automation which can increase more efficiency of your overall organization. These are the modernization pathways. How we can achieve the modernization in our, you know, for our organization, for our workloads. So the first thing is we need to move cloud native architecture. Why we need to move to the cloud native architecture? For example, if we are managing the databases on a virtual machine in our organization, and if we are using some pub-sub application and we are, managing it by ourselves, while migrating to the AWS, if we are going more cloud native, we are migrating to the, you know, if we need more agility, if we need more scalability in, if you are in the on-premises cloud and you want to, scale, the scalability and agility is not there, because if that load increases on your existing applications, you'll not be able to scale that much. You need to provision a new infrastructure or a new virtual machine in order to bear the load. We want all these things to be automated. So if we go more cloud native, if we build more containerized application, or if we build our applications into a monolith architecture, so each part of your application can scale independently. And whenever the load increases, you don't need to do anything. You don't need to add any virtual machines or computing power manually. It can increase automatically. So it will increase the agility of your applications. So whatever the load is coming to your application, you're ready for it. Your application can scale automatically. And the other modernization pathways, we need to migrate to the managed cloud services. So the managed cloud services, AWS has more than like 200 services for the AI, for the machine learning, for the databases, for the data lakes, for PubSub, everything AWS provides through its services. So while migrating to the AWS, we need to make sure that we are modernizing our architecture by embracing those services. For example, if we have some small task which we were doing, and we have deployed that application to the virtual machine in your on-premises system, while migrating to the cloud, you can offload the task to AWS Lambda function, which is a serverless offering. You're not managing any servers, and Lambda can do the job for you. So if there is any event-driven architecture, we can migrate to the AWS Lambda. Plus, if we are migrating, we need to make sure that we are using the managed database services. Many database services means that if you are migrating to the RDS from, let's say, MS SQL, which you are running on your virtual machine in your AWS, you are migrating to the RDS. You are not taking the daily snapshots manually. It is automated. If you want more read replicas of your databases, you can just within just few clicks, you can click create read replicas and offload the read queries to your read replica. Plus, if you want to take snapshots, if you want to recover your databases from that, everything can be done within few clicks if you are in your many databases. And the storage, it can scale automatically. So all these things increases the overall productivity of your application. So you are achieving the modernization by using the native AWS services and offloading the manual tasks. Plus, we can move to open source. We can free ourselves from the proprietary licensed software path, which can sometimes restrict ourselves when we want to operate on a bigger scale, or when we want to, have some scalability in our architecture. So while migrating, we can make sure that we are moving to open source tools as well in order to increase the efficiency and the agility and modernize our environment. So the efficiency moves up with the modernization. So in this chart, we can say that if we are on the on-premises cloud, the application code, the data source integrations, all these things we are doing and managed by the customers itself. The security and network configurations, the physical server security, the networking of this, the facility, managing the server, making sure it's heating and cooling, the provisioning of the infrastructure, installing the software, patching. Everything is the responsibility of the customer. So you are spending a lot of time in managing all these activities. While you are migrating to the AWS cloud, so let's say you migrate your infrastructure, you lift and shift, you rehost your infrastructure to the AWS EC2, for example. You will be managing your application code, you will be managing the integration, the capacity planning, scaling of your EC2 instances, installing the software on it, maintaining those EC2 instances, plus provisioning those. But you are offloading the physical server storage, the networking facility, the physical server security of your actual environment. So that is being managed by AWS. And you are not also managing the network configurations, the security of your actual physical servers. This is something also being managed by AWS. So you're managing on the security group level, on the EC2 level. So you have, while migrating to the EC2 instances, you have offloaded some of your tasks to AWS. Now, if you migrate your databases and your softwares to the managed platform, let's say RDS or ECS for containers, you are not provisioning the infrastructure as well. So you are just worrying about your databases and you are running it on RDS. So you are just running your containers on AWS ECS. You are not worrying about the underlying software and the underlying hardware maintenance. So everything is being managed by AWS now. So you see, you have offloaded few more tasks to the AWS while you are just worrying about your application code and the capacity planning. And when you go cloud native, you are using almost all the available services of the cloud based on your requirements. So for example, for your data source and integrations, for your capacity planning and scaling, for your software installation and maintenance and info, everything is being managed by AWS. The reason is that for example, if you are using Lambda or AWS Athena for your to run some queries on your data, so everything is being managed by AWS. You are not provisioning the infrastructure. You are not you know deciding, okay, how I will be scaling if there is a load or if I need more computing power. Everything is managed by AWS. You're not worrying about the capacity of the underlying hardware. You're not worrying about the capacity of the compute. You're not worrying about the software. You're not worrying about installing any packages. You're not worrying about the physical server security. Everything is being managed by AWS. You are just worried about your application code. So if you just have your application code, you can just do the focus on that, and rest everything is being taken care by AWS. So while migrating, we need to make sure that we are modernizing our environment so that it can increase our efficiency. So in this stage, almost all of your IT staff will be focused on your, business goals. They can focus on your business goals, how they can improve the business and focus on the more important tasks rather than managing everything manually by themselves. So serverless as one path for the modernization. Many people were talking about the serverless technology, how it is benefiting the a lot of organizations, in order to save a lot of cost. So the serverless strategy enables you to achieve the maximum value from the cloud. And by serverless, we're talking about applications that are built with technologies that eliminate the need to manage the servers. And you can scale, you know, infinitely, automatically to any extent, and you are just paying for the computing power which you are using. So you're just paying for the value, whatever you are using. You're not paying the value for the provisioning. In the on-premises and while you are on the EC2 instances, you usually pay what you have provisioned. For example, if you provision a machine with 8 vCPUs and 32 GB of memory, so you are paying for that. Even you are utilizing the 20% of it. You are paying for the provisioning capacity. So this is one of the big reasons that many organizations they want to adopt the serverless, because you are not paying for the provisioning capacity. You are paying for what you are using. So in the serverless, there is no server management. You are just bringing your application code and running it on the AWS cloud. It is flexible. It is automated scaling. If there is a load, if you want to scale your computing power, it can scale automatically. and it has 3 times more integrations. So for example, if you say that, okay, I have Node.js code, Python code, any sort of code which you have, you can bring it to the AWS Lambda. It has a lot of integrations and it is automated and highly available. You don't need to worry about the availability of the AWS Lambda. You don't need to worry about the, about the underlying infrastructure. Everything is being managed by AWS. You are just worrying about the application code. It will be automatically highly available, flexible, and efficient. So that's the power of the serverless. There are other serverless offerings for the databases as well. Let's say DynamoDB as well. It's a NoSQL database offering from the AWS. You can use DynamoDB to for your NoSQL databases, and it can also scale to maximum extent based on your demand. Now let's talk about the. So we are talking about the serverless. We're talking about going the microservices way. But how AWS can help you refactor your applications to go serverless and to refactor your applications to go to a microservices architecture. AWS has a service called AWS Migration Hub. So there are three primary benefits, that can help incrementally to refactor your application. So first of all, we need to use this orchestration service, AWS Migration Hub. So it will reduce the time and setup to manage a refactor environment for your applications. If you are, let's say, migrating 20 applications and you want to refactor and while migrating to this to the AWS, and if you want to manage it manually, it can take months for you to refactor those applications and deploy it on AWS. If you're using Migration Hub, it can take you can reduce the task into days. So using this orchestration service, it can reduce the your time to set up. Plus, it will shield your application consumers as you update the change the infrastructure and microservices. So while you are refactoring your applications, uh, you need to plan the infrastructure where you will be hosting your microservices architecture as well. So it can help you to for example, you have a monolith application. So while we are discussing about the migrating the monolith applications to the microservices architecture, so there's an AWS service called AWS App to Container. It can help us in transforming our applications from monolith architectures which we have deployed on EC2 instances to migrate them to the microservices architecture which we can deploy to Amazon ECS or EKS with minimal effort. So sometimes in our existing organization, we don't have that expertise to migrate the applications from monoliths to the microservices, but we want to achieve that. So AWS is helping the organizations, the customers, by using the app to container. We can migrate our legacy applications from monolith architectures to containerized architectures. So we can do the containerization and scales. Plus it also helps you by having the best practices for the containerizations. So it is also opinionated AWS deployment artifacts. You can create those artifacts and you can deploy it to the Amazon ECS, which is Elastic Container Service, or Amazon EKS, which is the Elastic Kubernetes Service. Based on your requirements, you can deploy that to any of these services. So app to container can help us in achieving the the containerization with the very few effort. So how it works? So we can transform our applications from virtual machines to the containers. Firstly, it will discover and analyze the existing application, and then it will extract the containerization. It will create all the dependencies and help us in building the Docker image. And that Docker image, we can from that Docker image we can create the artifact. That deployment artifact we can deploy it to any AWS service which is there for the Docker image deployment. Let's say Amazon ECR and EKS. We can store our image in the ECR repository and then deploy it to the ECS and EKS. So serverless to accelerate the modernization. So what are the AWS services which are there for us to adopt the serverless tools and technologies? For example, AWS Lambda. We can run any of our functions on the AWS Lambda and AWS Fargate. So these two compute services are serverless from AWS. It can scale on demand, and we are not managing or not provisioning any capacity for the computing, and it can scale up to the maximum level as well. And for the data stores, we have Amazon S3, we have Amazon Aurora serverless for the databases, and Amazon DynamoDB, which is a NoSQL database offering from AWS. And the Amazon S3, we can scale up to to petabytes, so we can bring as much as data as we want, and it can scale automatically and grow to our needs. Plus, if we talk about the integrations, if we have some APIs to run, or we need a queuing service, or we need a simple pub-sub application architecture, AWS has SNS, which is simple notification services, step functions, AWS AppSync, Amazon SQS is a queuing service. So we have a lot of services which we can use for in our application architecture for these integration purposes. So there's another service AWS which is called as AWS Proton. It's a managed application deployment service for containers and serverless. So we can increase the control of our cloud infrastructure by accelerating the pace of innovation. So our development teams, we just want them to focus on building the applications. That's it. We don't want to worry, make them worry about the infrastructure, how they will be deploying. We just want to give them a simple architecture which is ready to host their application. So this is where AWS Proton comes in. So for the infrastructure operators, they can create the application infrastructure templates. And once the templates are created, and in the AWS Proton, it can monitor plus also updates the deployments as well. So your development teams who are building some applications, they can just easily find and deploy their application infrastructure. So whenever they need the application infrastructure, using this AWS Proton service, they can deploy the application infrastructure and run their application on it in a very easy way. They don't need to, uh, create the infrastructure by themselves, or they are not dependent on any other, team. So whenever they need the infrastructure, they can just, plug the infrastructure and deploy their application on it. So the core features of the AWS Protons are it's a self-service interface for the developers. They don't need to depend on any other teams for this. Plus it's a centralized management and visibility. They can see the versioning, they can see the updates of their the infrastructure and the applications, and they can manage everything in a centralized way. So it has the version control for the templates. They can see that what are the changes have been done uh, in the infrastructure template, so they can see and control everything. They can go back, just like they are deploying their applications through the version control system. They can see the infrastructure as well, and using just one click they can upgrade to the newer versions. Plus they can create the infrastructure pipeline as well. They can automate that, just like we are creating the pipeline for our application code to be deployed. We can create the pipeline for our infrastructure templates to be deployed as well. Plus it has third-party integrations as well, which can help them in order to deploy their applications if they want any third-party integration. So AWS has another service called the EKS, so which is it's also a shared service platform. So it's just like a reference solution. So for example, if you want to deploy a shared service platform EKS, so you can just do it in days, not in months or years. For example, if you want to run a a cluster or a shared service platform on your on premises, so it will be very difficult for you, so to provision the infrastructure and do all the necessary configurations. But in AWS, we can create the infrastructure as a code. We can use the AWS CDK, we can use the Terraform, we can use the CloudFormation templates to build the infrastructure, which is based on the AWS best practices and recommendations. Plus, we can integrate it with popular Kubernetes tools and services, and it's a fully extensible and customizable service. So we can run our Kubernetes workloads on this EKS. We can automate the provisioning of the clusters, and it has all the set of best practices. So we can just bring our container images, and if we want to host it on the Kubernetes architecture, we can do that using this EKS service. Cloud ops. So as we talk about that, migrating and modernization is not just about the tools and technologies, it's about the operations. It's about the automated everything which we were doing manually. So for example, we can automate the management and governance part as well. So AWS has a lot of services which can help us in automating the governance. So we need to make sure that we are creating a financial management, financial budget while we are adopting in the AWS cloud. So to enable this, AWS has a service called AWS Control Tower. It can automate the provisioning. It can automate the implementation of the security best practices in the AWS account. Plus, there are three phases of it: enable, build, migrate, sustain, and then continuously operate it. So while we are building it, we can use the AWS code pipeline, AWS Migration Hub, CloudFormation template for the continuous building. So we are automating the creation of the infrastructure. We are automating the processes by using AWS Migration Hub. And once we are migrated, we need to operate. So we are continuously monitoring our cloud through AWS CloudWatch, and we are continuously improving the let's say if we want to patch something, if we want to install some packages, even we can automate that. If we have like hundreds of servers, we can use AWS Systems Manager to automate the patching, or to automate the to install the packages on all of the 100 servers. So while we are operating, we need to make sure that we are using the automation in each and every aspect. So while migrating to the cloud, we need to make sure that we are creating the cloud operations and financial management for our organization, so it can improve the overall security, overall governance of our AWS account. So AWS also has a services which can centrally manage your AWS accounts security findings. For example, you have multiple AWS accounts, and there's a service of AWS called Security Hub. So it can centralize the all the findings, and it can give you the visibility and what actions you need to take in order to make sure that you are fully compliant and secure uh, within your AWS account. So it can assess your account for all the vulnerabilities, and then it can recommend you. So it has the native integration with AWS Guard Duty, Amazon Macy, and other. If we have a third party solutions for, let's say, vulnerability assessment, we can integrate that with Security Hub, and in a centralized place it can help us with all the findings. That, for example, if we have a port 22 open for a Linux virtual machine, it can let us know that okay, we have this vulnerability, we can go over there and resolve it. So if whatever the system which we were doing on the on-premises, while migrating and modernizing, we need to make sure that we are using AWS services which can centralize the security findings, and which can centralize this security management of our AWS account. So modernization delivers the economic value as well. So while we are on the on-premises, we are managing all these things from the application architecture, environment, and infrastructure. Our cost is very high. It will be very high because we are putting a lot of effort on the people. The money is being spent on people. The money is being spent on the all the operational tasks they are using, and the money is spent on the physical host, their security, their maintenance. While you are lifting and shifting to the cloud, it can help you to reduce some of the cost because you are not managing the underlying servers. While you right size your infrastructure, you see that there are many EC2 machines or many servers which are not being utilized fully. So you can reduce the specs, you can reduce the vCPUs and RAM of your existing EC2 instances. You are continuously optimizing. While you are optimizing your pricing model, then you are going to the open source. You are modernizing your infrastructure. You are using open source technologies. You are reducing your cost furthermore. You are migrating to the many services of AWS. Let's say RDS. You are migrating to the uh, you know SQS. You are saving furthermore cost. Plus, you are increasing the efficiency as well because everything is being managed by AWS. Even you are not managing the operating system of the RDS database. You are just worrying about the database and using it. Plus, you are modernizing yourself and you are embracing the serverless architecture. In the serverless architecture, you will be just paying for what you are using. The efficiency will be high and you will be paying very less cost. Plus, it's a continuous operation. So you need to make sure that you are continuously evolving in the cloud and you are continuously modernizing your infrastructure, continuously building the new application, and you are continuously managing automating the manual tasks. So at this stage your cost will be very less and you will be having a very high efficiency and scalability, and whatever the services you want to provision, you can provision very fast. So this is a full journey of the modernization and it can bring a lot of economic value to you. And why AWS for the modernization? So AWS has a broader set of services where we can host our containerized applications and serverless applications. Plus, AWS Compute Services offers deep integration with the rest of the AWS 200 plus services. So if we are running our applications on, let's say, Lambda or Fargate, we can make sure that we are utilizing the other services of AWS, let's say S3, RDS databases. Plus, AWS supports and adopts a wide range of open source software. So AWS is a substantial contributor to the open source ecosystem as well. So AWS innovates and accelerate rate in releasing the services feature. So in 2016, in 2017, and 2018, AWS is releasing more and more services and features, and they will be continuously releasing those services in the future as well. So AWS is helping us in achieving the modernization so we can use the broader set of AWS services and modernize our infrastructure. So the actions which we recommend is ensure the executive sponsorship while you are migrating. You make sure that you have a team who is taking the responsibility for it. Identify the high business value workloads. During our initial assessment, we can identify that whatever the what are the workloads which are impacting the business value, and then we can move quickly on a smaller projects and learn. If we move on a smaller projects, we can make sure that we are learning from our mistakes so we are not applying those mistakes to our other smaller projects. We shouldn't be migrating in a very as a big project. We should be dividing our migration plus modernization into smaller chunks and build a smaller teams so they can work on it. Plus we can give serious consideration to bringing in a modernization advisory expert while you are modernizing and migrating to the AWS cloud. You can reach out to AWS partners, for example, like TecBrix, who can guide you in your modernization and migration journey and advise you on the what steps you should take, what is the best suitable migration strategy, what is the best suitable AWS offerings, what are the services which you can use based on our existing infrastructure. So these are the modernization strategies while we are migrating, we are discovering the existing infrastructure, we are assessing the application and workloads, then we are determining which path we need to take. Either we can refactor, redesign our applications, go serverless, or we can re-platform by uh, we can determine the platform, go to the RDS, we can repurchase For example, if we are running a legacy system, we can repurchase the system, go and buy the SaaS platform, or we can rehost. We can rehost it manually, or we can rehost it automatically using AWS tools. Rehosting is just the lift and shift. Even we can relocate. For example, if we are running VMware on the on-premises, we can run VMware on AWS cloud. Plus, there are some applications which we can retain, which we don't plan to migrate, and we can retire because those are not being utilized at all. We can retire those applications. So based on this assessment, we can define which strategy we need to take in order to make sure that we are getting the full value of the migration. Uh, while migrating, how you can define that which strategy we can take. For example, if you have the VMware workloads or Windows EC2 instances, or you're running SQL instances on EC2 on your on-premises, you can just relocate or rehost on the AWS cloud. And then from the on-premises, you can go to the more cloud native. So for the SQL Server on EC2, you can go to the SQL Server on the RDS instance, for example, and re-platform. If you have a containerized applications and you want to deploy faster, you can deploy your applications through the ECS, Fargate, as a which is a serverless offering, and Amazon Elastic Kubernetes services as well. So if you are running, let's say, uh, RDS SQL on a virtual machine, you can migrate that to the managed service of the RDS. So you can re-platform your application, containerized workloads, migrate them to these services, and the database workloads, migrate them to the RDS SQL. Plus refactor application, move to the open source. For example, if you are running the .NET application on your on-premises, you can migrate the .NET application to the .NET Core and free yourself from the licensing, which is called as the license freedom. It can save a lots of commercial benefit for you. You can save a lot of money, and you can deploy your application. Let's say you can either containerize it or deploy it on EC2 instances without paying for the licenses. Plus, if you want high performance and scalable purpose-built databases, you can refactor your application and use the native AWS services so that you can gain the high performance. So based on the journey, based on the assessment, we can choose the journey which we want to choose and modernize. So this is a map modernization pathway as well, where it has the three phases. One is the assessment, other is the migration and mobilization, and other is the modernization. So first, if we have the legacy applications, we can rehost. From rehosting, we can go more cloud native, or we can directly go refactor our application and do the modernization. If we have the databases, we can rehost on the cloud, migrate on the cloud, and then move to the managed databases so that we can gain the maximum benefit. Plus, if we have the Windows, we have commercial on-premises, the licenses we're running on on-premises, we can migrate, we can bring our licenses to the cloud, and from there we can, you know, migrate our applications, move to the open source by refactoring them to the .NET Core, or and then using the Linux operating system to deploy our applications. So all this migration paths, the journey, based on our assessment, we can guide you on that. So which path we need to take in order to, to migrate and modernize. So the approach will be doing the assessment and discovery of the existing infrastructure. We'll be making sure that we are understanding all the tools and technologies, clarifying everything, all the phases, and then we'll be, defining our targets, that which application we want to modernize, which application we want to rehost, which applications we want to retain, and then what will be the target databases, and then we'll be doing the application modernization. We'll be tracking all the business changes, migrating our applications to the containerizations, and doing the continuous changes, and then we can do the transition. We are fully transit from the on-premises to the modernized environment. And then we can get the ongoing support. We can create a benchmark for our new applications. We can create the continuous improvement and do the strategic planning as well for the next upcoming applications, what we need to do. So the best way to build a modern application is understand the architecture patterns, go to the modular service and build the operation model. So if it is as serverless as possible, if it is as managed by AWS as possible, it will be beneficial for us. And how we can increase the developer agility by automating and all the tasks and doing some standardization around that. Plus, we can create some programmatic guidelines. We can do the management and governance. Plus, we can decouple and purpose build the databases, the architecture components of the application. We want to make sure that we are building a decoupled architecture. No architecture should be, depending on each other. It should be a separate component. If it is a data, if it's a caching layer, anything, it should be a separate component. So while building the application, we need to make sure that we are considering these points in order to build a efficient and a modern application. So this is just an example. If we have a monolith application which is having a application code, a caching layer, and a database is in a single platform, uh, it's a blue book, it's a bookstore, for example. While refactoring or while migrating them to the modernized architecture, we can create a storefront as a separate component, service and repair as a separate component, catalog API, content API, and the ownership and the research, everything as a separate component as a decoupled architecture, so we can improve the overall efficiency of the application. So TecBrix can help you in order to achieve all this application modernization and infrastructure modernization because we have a pool of highly skilled specialists and we have the methodologies around that. We can help you in the assessment of your existing environment, existing applications, and based on the assessment we can recommend you the guidelines. We can recommend you what is the best scenario for you to migrate and modernize on the AWS cloud. Plus we can accelerate all this through some our packaged offerings and our managed services. So thank you so much, guys. That's it from my side. If you have any questions, you may please ask.
Hi everyone, I have a question. May I?
Yeah, yeah, please.
Okay, first of all, thank you so much for always spending time and efforts and educating us in such relatable topics. As you said that TechBricks is helping in modernization, so I would like to know, especially in the context of security, that how TechBricks address and mitigate potential risks associated with modernized applications, and how does it make sure that the current operations that are going on in the organizations uh, how does it basically cater those
Hmm.
and they do not get disturbed.
Okay, great. So, when we plan to migrate and when we plan to modernize to the AWS cloud, so the first phase will be the assessment. So during the assessment phase, we will understand the existing operations, whatever the organizations is being doing, and we'll be doing the gap analysis that while migrating to the AWS cloud, these are the gaps identified in our assessment. And while migrating through all these things, we need to make sure that we need to take care of that. And we will prepare the gap analysis report and share with the customer that these are the things as per the security best practices we need to adopt while we are in the AWS cloud. And plus when we build the the infrastructure for the applications to migrate, let's say we build the landing zone, we will make sure that all the operations, all the accounts, and all the AWS security best practices, we have a standardized offering, we have a standardized templates for that, which can make sure that all the when the customer will be migrated, and for their continuous operations, they will be secure and efficient.
All right, thank you. That makes sense. Also, is there any specific industries that TecBrix is serving in, for example, doing migration and modernization, or are there any use cases where TecBrix has helped bring an impact in AWS transaction?
Yeah. So we have migrated and modernized the many applications for the financial industry as well, for the uh, insurance industry as well. So there is an insurance customer who was running his application on premises. So they were having downtime, let's say very often, 2-3 times in a month, and it was a business critical application. We helped them migrating that application to the AWS cloud. We didn't only migrated that, we modernized the application and we deployed into the AWS ECS. We containerized the application and we make sure that we are using the native and the serverless offering of AWS. And then after that application being migrated to the AWS cloud, it's been like 3 years and they didn't face us downtime of even a single second. So that's how we are helping the organizations in migrating from the monolith architectures from on-premises to AWS cloud. We are not just helping the e-commerce and these industries. We are helping the financial and insurance industries as well, where they have complex applications, and we are helping them to migrate plus modernize on AWS.
Right, so you guys are catering diverse industries. Okay, thank you so much. Thank you.
Thank you. Okay, thank you everyone for joining, and surely we'll see you in our next webinar.